So this year, American Mathematics Competitions 8 ended on Monday. So we know that in this competition, there are 25 questions, and you need to solve it in 40 minutes. So you have less than 2 minutes to solve a question. Rigorously speaking, actually, it's 96 seconds. So, in order to achieve a decent score in AMC 8, you not only need to know how to solve these questions, you also, more importantly, you need to solve these questions more efficiently. And I'm going to give a 5-part video explanation which talks about how I solve all these problems by topics, and hopefully by showing how I think about these problems, it can help you improve your efficiency in doing AMC8 type problems. So in AMC8, there's one type of problems that appears always most frequent in the context. And that type of problems is called word problems. Of course, word problems could have different types. So it could be related to percentage, it could be related to speed, and also some related to average and so on. And for all these word problems, of course, every problem can be solved by the equation. But I prefer to use a arithmetic method. In this year's competition, there are 6 word problems by my classification. So I will show you one by one in this first part of the video on how I solve it. So the first question is a word problem, which is fairly simple. It talks about how you spend $30 to buy sandwiches and soft drinks. Given that you want to buy sandwiches as much as possible, so this question, effectively speaking, is you need to do a division. $30 divided by $4.5. But that is not that easy, given that this is a decimal number as divisor. So we know that it's always easy to do multiplication than do the division. So what my method would be, let's do an estimation instead. So how many 4.5 would be around $30? And we know 30 is 5 times 6. So if you round up this to 5, then you know that you can put 6 here. But of course, 4.5 times 6 is not 30. 4 times 6 is 24. 0.5 times 6 is 3. So altogether, that's $27. So you buy 6 sandwiches, you will spend $27 with $3 left. Of course, $3 is not enough to buy the other sandwich, so you have to use them to buy soft drinks, 3 soft drinks. Then add up together, that's exactly $30. So we know the answer to this question is just 6 plus 3. You buy 9 items altogether. That is question 1. And we should aim to finish easy questions like question 1 in definitely within a minute and maybe in 30 seconds. The next word problem is question 7, which is a problem about average. So a person takes 5 exams, 3 already finished, and with some scores, 76, 94, and 87. And his goal is to reach the average of 81. And we want to discuss what could be the 2 remaining scores. And for these 2 scores, the question asks, what could be the smallest score for one test? So in order to achieve this average, if you want one score to be as small as possible, then the other score must be as big as possible. So we can assume that this guy must have one exam, which is a full mark. That's 100 points. And then we see what could be this missing score to make the whole average 81. So average 81 is actually means the sum of them divided by 5 is 81. Of course, you can use 81 times 5 and then doing the subtraction. But for average problem, a better method would be you use benchmark to do the calculation. What is a benchmark? Benchmark is just the average. So what I mean is you compare every number with the average to see what is the surplus and deficit, and then you do the calculation. That normally can make things easier. So particular in this question, what shall we do? So we see for these scores that have already been given, what would be the difference with 81? So for 76, definitely it has a deficit, -5. So 94 minus 81 is 13. So here this has a positive contribution of 30 points. And 87 minus 81 is 6. And for that higher score, 100, the difference with 181 would be 19. So now we calculate the difference of all the numbers with 81. Given the average is 81, so all this difference should add up to 0. Okay, then how can we make them to be 0? So 13 plus 6 is 19. There's another 19, so which is 38. 38 minus 5 is 33. So that means in order to make all these surplus and deficit add up to 0, here we should have -33. So then, what should be this lowest possible score? It should be 81 minus this 33. So the answer is just 48. We finish this question. The next question is question 8, which is a word problem related to percentage. So Alice has some marbles that she distributes to 3 other persons. So for the starting point is a bag of marbles. Then what would be the percentage for that whole bag of marbles? Of course, that would be 1, which is 100%. Now the condition states that she gives 20% to the first person, Pedro. So Pedro has 20%. Then what's left? Left would be 1 minus 20%, or 100 minus 20%. So we know that would be 80%. And for this 80%, Iboni took 10% of that. So 1 minus 20%, 80%, then times the other 10%. What do we get? So 10% of 80%. So is 10% means something divided by 10. So 80 divided by 10. So that would be 8%. How much that her sister Jamie get is always related to what's left after Pedro and Ebony took. So Pedro and Ebony altogether took 20 and 8%. So what's left it would be 1 minus 20% minus 8%. What is that percentage? 100 minus 20 is 80. 80 minus 8 is 72. So this is actually 72%. How much does Jamie took? Jamie takes 25% of what's left. So this multiplied by 25%. So 25% is what? 25% is essentially 1/4. So something multiplied 25%, the quickest way to do it is divide this number by 4. So 72 divided by 4 is 18. So that would be 18%. Now the question asks, what's left for the original person Gilda? Of course, that would be just y, which is 100%, minus 20%, minus 8%, and we know that is 72, right? Then minus 18% again. So 72 minus 18, that is 50%. So we get the answer to question 8. Question 16 is a speed distance problem. And the thing that makes it a little bit difficult is it also talking about the average speed. So it mingles with the average problem. And for the speed problem, what is the basic formula? So you should remember that there are 3 basic things when we talk about the speed. So speed, by definition, is actually the distance traveled divided by the time spent. So to write this formula shortly would be distance equals time times speed. Of course, we can also written as distance divided by time is speed, or distance divided by speed is time. But this would be the basic things that link the 3 things in speed problems. Now let's write down all the conditions. In here, this Qiang, actually his journey is divided into 2 parts. The first part is how long? When we're talking about distance, the first part is 15 miles. Do we know the time? Not yet. Do we know the speed? We know. That is 30 miles per hour. Now, in this first journey, if we know that he traveled 15 miles by the speed of 30 miles per hour, so every hour 30 miles, so 15 miles, so that's half an hour, right? So the time is actually easy to calculate, that half an hour. Or in other words, 30 minutes, we can put it down here. And then, for the second part of the journey, his speed becomes much faster, which is 50 miles per hour, 55 miles per hour. Okay, do we know how much time spent? No, we don't know. Do we know what is distance? We don't know yet. Okay, so that's about the second journey. But there's one more condition, and the condition is the average speed is 50 miles per hour. So average speed is 50 miles per hour. Okay, so this question makes sense because the average 50 is between 30 and 55. For average problem, the thing I always like to do is to use the ratio method. What do I mean the ratio method? So, you have 2 different speeds. To compare this, what is the difference between the average speed versus 30 miles per hour? Of course, it's kind of slower. What's the slower part? It's 20 miles per hour, right? And what is the difference between average speed and faster speed? It's plus 5 miles per hour. Okay, so now let us consider one question, which is for these 2 different speeds, which speed travels more time? Of course, the answer should be what? It should be these 50 miles per hour. Why is that? Because every hour at this speed, actually you travel 20 miles less compared with the required average. But at this faster speed, you can only catch up how many miles per hour? You can only catch up 5 miles per hour. So this every miles per hour So for this slower speed, every hour you would be 20 miles. You would have kind of like 20 miles deficit, and this plus miles is kind of surplus. But giving the average as 40, so the deficit and the surplus should be the same. In other words, you should have more hours traveled at this 50 miles per hour. So the ratio of 20 to 5 is actually, the ratio of 20 to 5 is 4 to 1. And that 4 to 1 is actually should show up the time span for these two different journeys, with different speed. So, but with a reverse order. In other words, what I want to see is if this guy travels at 1 unit for 30 miles per hour, he must travel at a faster speed for longer hours, which is full unit, to catch up in order to make sure that the average reaches 50. So if we know the time span is 1 to 4, right? I write as a unit. It's 1 to 4. So 1 unit is half an hour, what is 4 units? 4 units, of course, would be 2 hours. So at this faster speed, Chiang travels 2 hours. So 2 times 55 miles per hour, that would be 110 miles. That is the distance traveled at the faster speed. So you see, using this kind of ratio, you can get the answer fairly quick. Of course, if you haven't solved this kind of method yet, you need to think a little bit more about why this ratio works. But this really the quickest method to solve average related problems. Okay, now question 22 also related to percentage. So you have certain merchandise, and first its price increased and then its price decreased, and in the end the result is 85% of the original price. So for this one, I think we can write down an equation to show that. So from the original price, it increased by a certain percentage, so the price would become 1 plus X percent. And then the price dropped by the same percentage. So it will be 1 minus X percent. And the combined result is 84%. And once you have this kind of expression, two numbers add up, two numbers are different, and then you make a product, you should remember one formula, one very basic formula. And that formula is what? A plus B times A minus B equals A squared minus B squared. Of course, there are also other similar formulas related to that, which what is A plus B squared? A squared plus 2AB plus B squared. What is A minus B squared? A squared minus 2AB plus B squared. All these kind of algebraic formulas you need to remember accurately and clearly, so that each time you see some pattern, some expressions that has such pattern, you can use these formulas. So here, by using this formula, we can directly simplify the left side into what? Into 1 square, which is 1. Minus this b can be regarded as x percentage square equals 84 square. Giving there, here's 1. Maybe we change this 84% just to a decimal. So 0.84. So 1 minus 1 equals 0.84. Of course, this would be 0.16. So 0.16. So x percent square is 0.16. So 4 times 4 is 16. So you could easily see that x% should be 0.4. 0.4 times 0.4, so you have two decimals, 0.16. Which 0.4 just means what? It just means 40%. So we solve this question. Again, this is effectively a simple quadratic equation. That is question 22. Question 23 is probably the hardest word problem in this computation. However, if you use the right method to set up the unknowns or to set up the units, you will see this is a straightforward question. So in this question, it talks about a team that earns a total score, and they state what is the contribution of each person. So for A, he contributed 1/4 of the total score. For B, it contributed 2/7. And these two conditions are related to fractions. So then what would be the right way to set up the unknown, even if you want to set up an equation to solve it? I think in the standard textbook, they always say, let's assume the total score is x. And then we have 1/4 of x. We have 2/7 of x. And then we do the calculation. That is not the best method. What is the best method? Which is how we assume the total score. The total score, of course, is the integer. And that integer should be divisible by 4. Also, that total score should be also divisible by 7. That's why we can have these fractions. If the total score is 3, A cannot contribute 1/4 of the scores. So a number that is divisible by both 4 and 7 is what? It has to be divisible by 4 times 7, which is 28. So the right way to set up the unknown or to set up the total score is you assume the total score is 28U, where U, I mean units. And that is the right way to set up the unknown. So I set up the unknown effectively as U, but my unit is small. My unit is small so that all the calculations becomes integers. That makes our life much easier. So if you assume the total score is 28 units, what would be the score for A? 28U divided by 4, so this 7U. What would be the score for B? 28 times 2/7. 28 divided by 7 is 4. 2 times 4 is 8 units. So this would be 8 units. Okay, then it's pretty clear, right? So altogether it's 28 units. A has 7 units, B contributes 8 units. So the remaining person should altogether contribute 28 by 7 by 8. It would be 13 units. Okay, now we can continue to read what are the conditions for the other people. So C has 15 points. How about D? Which means other people. So other people, the other 7 people, everyone get most 2. So altogether they have at most what? They have at most 2 times 7, which is 14 points. Okay, now here it is a 13 unit. So add up is that. This thing add up is 13 unit. So if U is 1, that is not possible, right? Because at least this has 15 points. So U cannot be 1. How about U equals 2? If U equals 2, then that means all the other person altogether earned 26 points. So 26 points minus the number of points earned by C, 15 points, you get 11. So that are the number of points that possibly earned by the other 7 people. So that is a possible answer. Of course, as a multiple choice question, you can already stop here. But we can just do an analysis one step more, see what happens if U is bigger. But U is bigger, it's impossible, because if U is at least 3, then the total score has to be at least 3 times 13, which is 39, which definitely surpasses this 15 plus 14. So yes, it's really impossible. The only choice is U is 2, and the other 7 people earn 11 points. So you'll see all this calculation becomes simple just because we assume the total score is not a single X but 28 units. That is question 23.